Here we go. We're here. We're back. Um, let's set up our work environment again real quick. Hope the first part of your work, you got a drink with you. I'm drinking some nice brandy. And we're going to do some C coding. We have to find out where we are. I don't remember. I've been coding other things all day. But we're going to pick up where we left off and keep working through the book. We are done with chapter 1, if I remember right. We're going to start chapter 2. So actually, let me exit out of my tmux here and start a new directory for that. Directory S keys, make directory chapter 02. Chapter 02. And we'll set our tmux session up in here. And I'll go ahead and I need to automate this, but for now, I've just been doing this since I got off the green screen. So I hated that green screen. I'm so glad it's gone. Y'all probably don't care either. My closet's even open. I really don't give a shit anymore. Thanks for the follow. Chomsky Seal. What a name. So we're going to do a little bit of C game dev. We're working from a standard textbook. Chonky Seal. I thought it said Chomsky, like, Chomsky. It's a person out there who exists. So we need to go back to our book. Where is our book? I gotta find the book. Where's the book? By the way, just a reminder, tomorrow night is not C coding. Tomorrow night we're going to be hacking. So Sunday nights we hack. Every other night we're doing C game dev until we finish the book. And we're just working through the book and making, riffing off of things that are happening there. The book is not for beginners, by the way. The book assumes that you already know some level of coding, but I'm trying to help people that don't know any coding to kind of be okay with it as best I can. But if you really want to get going with stuff, you should probably start doing the boost. I'm going to say this every time at the beginning. I'm going to start saying this at the beginning every time. So, Giver Boost. This is a boost from 2021. It's kind of a series of videos that get you going with coding in Linux and stuff like that. I'm always adapting and changing how I like to do that stuff, but this is basically the same sort of stuff. Next year, by the way, this year coming up, it's going to be project based. So we're going to get our legs under us with Linux and the terminal through containers, and then we're gonna jump right into coding. But we're gonna be doing we're gonna be doing, when we get into coding, we're gonna be doing Bash, POSIX, and PowerShell, and then we're gonna learn Python and Go at the same time, following the Python the hard way series, and we'll be coding the same projects in Go at the same time. And C is the head for C. Is actually meant to be like the third or fourth in the series, and then getting good. So this is all scheduled for 2022. And people think about 2022 at the end of 2021 here. That's what's scheduled. However, my year starts in May. So May the 4th is when the new cycle will begin. So our first becoming an autodidact series will start on May the 4th. And then the rest of these courses will proceed throughout probably the whole year. And we're going to try to cram as much as we can. I think this might be a little this is going to be really full. We're only going to spend 90 minutes a day every day, but we're going to work every day. And except for Sunday, when we're going to do hacking on Sunday. So that's coming, in case you're wondering. Some of these other courses and stuff I'm working on my own. If we do them, they will be they'll be different. It'll be a different time during the day or the week, depending on how far we're getting. I'm working on passing my CCAD and CK and all that myself right now. All right, so let's see. I don't know what I mean. Head first, you suppose dive in Streamline. So it's hands first. Head first C. I don't know. It's some sort of play on words that they invented. You can read about it in the book. So I'm going to actually open the book. I have 2 copies of it that I paid for, and this is my PDF. So we're working on chapter 2. Let's just jump right in, and get going. It's all negative because dark mode. Again, Hipper C's whole thing is to be silly, so you'll remember it, and it works. It's based on science. Thank heavens my boyfriend isn't a read-only, isn't in read-only memory. Lol. What are you pointing at? Looks like we're going to do pointers. All right, this is notoriously the most complicated, most difficult, most frustrating, most intimidating topic in all of C to cover, and it's actually not that bad. So I want everybody to take a deep breath before we jump in, because C pointers, you say C pointers to some people and they're running around screaming. So it's important that you understand it. If there's one reason to learn C, it's so that you understand memory and pointers. So when other people tell you that their language is more memory safe, you can say, what does that mean? And you know what they mean when they tell you. Otherwise, you don't know what they mean. So it's important to learn these things. C is, again, it's the most powerful, ubiquitous language on planet Earth. The Unix operating system and Linux the Unix operating system was created with C, and C was created to make the Unix operating system, and Linux came from Unix. So you could make the case that C is responsible for every single computer that you're using right now. Every single one. Every device you have is running some form of C. So I have to say this every time we start this, because people love to shit on C and say all the problems it has because of memory overflow and all that stuff. And that's because it's so powerful and it's so low level that you have to have an extremely high degree of responsibility when you're using it. And if you don't have that, use one of those other languages. But there's nothing wrong with coding in C as long as you understand how. And you need to understand how, because C is the fastest language on planet Earth, except for assembly. There's no debating that. And let's go from there. All right. So if you really want to kick butt with C, you need to understand how C handles memory. That's what I've been saying. Chomsky Steele says, I've been doing C kernel development for a long time now professionally, and I still scream whenever I see pointer arithmetic, including my own. The amount of C off by one error is it causing that to excuse me. I just made an off by one error last week. Yeah. Off by one it's the killer, man. It really is. It really is. But you know what? It's acceptable. It's acceptable because you're dealing, the alternative is assembly. So people get mad at C all the time because they're comparing it to like fucking Python or Rust or Go. And it's not fair. It's not fair to compare them. Comparing C to assembly. When you code in assembly, I love this about the Gulagum projects, because they have you code in assembly for the first 22 lessons, and then they have you go back and do the same 22 lessons in C. And by the time you get to C, you're like, oh my God, thank you. Thank you, C. Thank you for being alive. Thank you for existing. Thank you for all of your quirks. Oh my God, yes, those pointers. Remember all those things? I was using those in assembly. Now I know what they're about, and I can do them more easily in C. So if you're going to compare C to any other language, it's Gulagum. Yeah, you probably really like it, actually. The Gulagum, I really love his approach. He teaches you assembly by simplifying the chips you do the work on, and rather than simplifying the explanation on a really seriously big chip. Like learning assembly on x86 is fucking insane, but they teach you a microchip pick. Gulagum tutorials. The PIC tutorials, here they are right here. So there's a big plug. I'm not getting paid by this, but I just really believe in it. I have like 15 or 20 kits that are just going unused here. But if you want to learn how if you want to learn assembly, and then you want to learn C and appreciate it, this is definitely the way to do it. If you like low-level engineering stuff, this comes with a board. This isn't game development, but it comes with a board, and then you put the chip in there and you code it. The chips actually go in here, and you can actually do LEDs and all kinds of stuff. You can make these LEDs flash and everything. And all the coding is done with a microchip pick. As the first instruction in the Intel manual, AAA. That's what you'll yell when you read what it does. ASCII adjust after addition. I believe it. And I don't know how to do that. I've always wanted to know. In fact, I still have to go. One of the things you're going to see me do on stream is I'm going to go through all of the tutorials in assembly and in C on one of these Gulagum boards, and I'm going to do that. And now I wasn't able to do that before because I didn't have IRL streaming capability. I didn't have cameras and stuff to show me working with the board, but I have all of that now. I actually added that 3 weeks ago. So I have all that capability. That's also why I'm going to be streaming my creation of my Kubernetes cluster back here on hardware and, making network cable and blah, blah, blah. So I have all that capability now, and that was the only thing that was stopping me. So you're going to see me doing a lot. We're gonna do assembly on Microtip PIC controllers on the stream and have fun with it. You all can laugh at me, but I've dreamed of becoming a computer engineer at one point. So what does all of this have to do with C game development? Because C is a better assembly. And if you look at it that way, if you stop comparing C to Go and Rust and JavaScript and Python and Ruby and all these other super duper high level languages, you'll appreciate it. You'll be grateful for it compared to assembly. You won't be bagging on it for all of its quirks and negativity. Let's see. I like from the ground up too, because Java tutorials like, yeah, that's what's so great about this approach, Ancient Streets. The really great thing about his approach is he says, look, we are going to start with the smallest possible microcontroller you can buy and the simplest possible programming you can buy and do. Assembly on a Microchip PIC-8, which is a tiny, tiny little chip. It costs you like half a cent or 2 cents to get one. And this is the thing that's in all your Christmas lights and everything. And so you learn how to program the simplest possible chips. And then you're like, oh, that's how it works. And then you get to another chip and you're like, wait a second, the language has changed. The language changed because all the memory addresses changed. And then you start to realize assembly is actually about what the device gives you. And that's why I have to memorize memory registers and everything. I don't know anything about what I'm talking about. I know that I'm going there. I'm super excited. And then when you get up to one that actually has, I think, a sequencer on it. I think it's what is it? And once you have a sequencer available to you, you're like, oh my God, I got this really cool hardware device on my Microchip PIC that I can use that I didn't have before. So now I can do things like, oh, I don't know, sleep. Because sleep is how fast it loops through the thing. It's super cool. And it's like you build up and up and up and up and up until you get to the bigger stuff. And so by the time, you get thrown at, assembly, coding, evaluation, or you go through and look at the C assembly converter, which I haven't showed anybody yet. I can't wait to show you. Then you start to understand what's going on. All right. So, and it's fun. The whole thing is fun. It's all game development. It's like hardware games at that point. People hate NC, but it's the only thing you can write the trickiest bits of an OS in without swearing too much, at least today. I agree. It was not fun. Assembly coding, I think assembly coding would be crazy fun. I can't wait. It's going to burn my brain. Absolutely. So back to the book. The C language gives you a lot more control over how your program uses computer's memory. In this chapter, the reason people say C is dangerous is because it does give you so much direct control over memory, including memory that you shouldn't be accessing. And if you're a hacker, that's a good thing. If you're a hacker, you want to know this shit. And I aspire to be a good hacker, and I think y'all should learn to hack too, because it's good for you. It's good for you. You want to understand where to find bugs in 0 days. It'll make you millions of dollars. Learn C. Maybe you'll find the next hardware backdoor. You never know. In firmware. You just might. The C language gives you a lot more control over how your program uses computer memory. In this chapter, you'll strip back the covers and see exactly what happens when you read and write variables. You'll learn how arrays work. See, they're assuming you know what a variable is, right? So, X and Y and name equals Rob or whatever. You'll learn how arrays work, how to avoid some nasty memory snafus, and most of all, how to master pointers in memory addressing, which is a fundamental part of assembly. In fact, computing is all about just moving the pointer around as to what thing it's pointing at any given time. And that thing it's pointing at is just a 1 or a 0 at the end of the day. Or if it's a byte, it's a 1 or a 0 at the beginning of the byte. And this is where actually understanding Turing machines and stuff like that starts to get really interesting to me. We're not going to go down that rabbit hole right now, but I really, really, really want to understand that. And you can't understand it without understanding assembly, because that is how computing is actually happening at this really, really lowest level. And I'm super fascinated by it, but it's not necessary to make a game using that stuff, obviously. Become like a kick-ass C programmer. Oh, they said kick-ass in there. All right. C code includes pointers. Pointers are one of the most fundamental things to understand in the C language. So, what's a pointer? The pointer is just the address of a piece of data in memory. A number. It's a number. Addresses pointers are used in C for a couple of reasons. One, instead of passing around a whole copy of the data, you can just pass the pointer. It's called pass by ref, right? And most things in Go and other languages, any other language, are pass by ref. They're not passing around. Can you imagine them lugging like 2 bytes of that video MPEG file that you just know? Or even if it was loaded into memory, I mean, rather large, like 2 or 3 pages of HTML. You don't want to actually pass all of those bytes, so you pass a pointer to the first position in that, and you figure out some way to tell it how long it is. If you find CPUs interesting, I believe there are a number of good ones, toy CPUs. You can flash to FPGAs written in BlueSpec. Nice. I'll have to go give that a shot. Thank you, Chomsky Seal. Appreciate that. I've got the answer you need right here. It's in your Encyclopedia Britannica. C is pass by value or pass by ref. It depends. That's what I'm trying to say. By default, C is pass by value unless you tell it you want to pass by ref. I'm almost positive that's true, but we're about to read it. This is a copy of the information you need. Look at all that. It's like a ton of information. Or you could just look at page 241. This is a pointer to the location for the information. You might want 2 pieces of code to work together. God, that inversion is kind of getting to me now. You might want 2 pieces of code that work on the same piece of data rather than on a separate copy. You were supposed to sign the birthday card we left in the lunchroom, not another new one. But I prefer this one. It's got kittens. So they made a new one. That's pretty lame. Relax. Don't try to rush this chapter. Pointers are a simple idea, but you need to take your time to understand them. Take frequent breaks. Drink plenty of water and booze. And if you really get stuck, take a long bath. And drink a nice tea or perhaps a large brandy. To quote Dumbledore. Does anybody know what Harry Potter that was in? That does not pass by value as others do. It's passed by value without exception. Passing a pointer as a parameter does not mean pass by reference. You're right. You're passing a pointer, which is a number, so it's always passed by value. Okay, let's restate that. Thank you for that. So C is always passed by value. It just so happens that one of the values is a number, which is a pointer, and it's a rather small value, relatively speaking, right? It's always passed by value. C is always passed by value. I like that. All right. Pointers help you do things to do both these things. Avoid copies and share data. But if pointers are, you know what? I'm gonna make a Zetkasten thing about that. C is always pass by value. I'm gonna remind myself of that. A pointer is still a value. Okay, I gotta remind myself of that. So, oh fuck. Swap pane 1 and 2. 1, 2, 2. Chance char as a number, which is a memory address, but before you're thinking of it as a string. No, absolutely not. Yes. All right. Where were we? All right. Pointers help you do things with copies of the data. But if pointers are just addresses, why do some people find them confusing? Hope I got to answer this. It's my wife. Sorry. All right. If you're not careful, you can quickly get lost chasing pointers through memory. The trick to learning how to use C pointers is to go slowly. All right, well, that's pretty damn slow. A lot of sources are 404. Damn it. F sort of expects people who automatically think, are you looking for head first C? It's all over in GitHub if you want it. This technically means passing one character to a function takes less memory than taking the reference of the character and passing that to a function. Hell yeah. Depends on what you're passing, right? Single instance shards aren't passed by pointers, right? All right, so here we go. Here's our diagram of the memory, the stack, the heap, the globals, and everything. We've used this before, right? This is how the executable gets put together. To understand what pointers, dig into memory. To understand what pointers are, you need to dig into the memory of the computer. So, ancient bricks, yes. Every time you declare a variable, a computer creates a space for you somewhere in memory. So when you create a variable, greeting equals hello world. If you declare a variable inside of a function like main, the computer will store it in a section of memory called the stack. So if it's in a function, it goes into the stack. X lives at location 4,100,100. What is that? Yeah. The computer will store it in a section of memory called the stack. If a variable is declared outside a function, this is C, by the way, it will be stored in the global section of memory, down here with the constants, right? These don't ever change. Okay, so you got that, and otherwise the stack is getting changed all the time, right? Or is that the heap? I might have it wrong. Just keep reading. Variable y will live in the global section because why? Because it's out here. And its memory address is 1 million, value 1. Y is an int, and it's like whatever. Int main, int x equals 4. Variable x will live in the stack memory address 4,100,000. The computer might allocate, say, memory location 4,100,000 in the stack for the x variable. If you assign the number 4 to the variable, the computer will store 4 at that location. Because the address space is split by word size padding. Yes, Tim, I agree. Frank was talking about that. This is a simplification, right? If you want to find out the memory address of the variable, there's some other stuff that we're talked about here that were wrong too. So for example, we found out that the compiler was inlining string literals. There's some difference between how string literals are handled. And we were looking at that the other time too. So if you thank you for the fall. If you want to find out the memory address of a variable, you can use the ampersand or the and sign operator. The and sign is the address of x. So it's not x, it's the address of x, which can get crazy because if you take the address of an int, it's kind of the same thing. They're both numbers. So printf x is stored at p. Ooh, look, it'll give you the pointer. So there is a type %p for printing the pointer address of a thing. This is really fun. Let's go play around with this. This is what the code will print. X is stored at blah, 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 blah. Some big ass number that is in your total memory. And I believe that's only onboard RAM, right? That doesn't include any caching or anything. The memory address, I think, is a memory address in RAM. Am I correct on that? I think it's the memory address in RAM. Blazing fast 300 gigabyte alternative modules to get the memory address. Oh god. So what I want to know is, yeah, I'm pretty sure it's RAM. So in order to know the maximum number, you'd have to know how much RAM you have. And this number would represent that. Oh, yeah, this is a great comment. It depends on the CPU. Yes, generally you do want your address to be aligned. If you want to reference a 64-bit integer, you should probably make sure it's 8-byte aligned. That is to say that the address mod 8 is 0, so it evenly divisible by 8. Normally checked with address mod 7 equals 0. x86-64 lets you have unaligned accesses, but it has to do extra check stuff as it and is usually a bit slower. Some RISC CPUs throw exceptions for unaligned accesses. Interesting. This is super interesting. I'm so glad you're here. We have a Linux kernel developer in the house today, which is just fucking amazing. Thank you so much for being here. I feel so humbled by my little C expert. I did make a kick-ass fork bomb in C, and I was paid to do it for IBM to test some performance monitoring stuff. And that's my claim to fame. The only other C code I did was like just debugging stuff and tiny stuff. Papa OS is so busted right now. Okay, anyway, so let's get on with this. Let's write some code. So the address of the variable tells you where to find the variable in memory. That's why an address is also called a pointer. Because it points to the variable in memory. Pointer. And a variable declared inside a function is usually stored in the stack. A variable declared outside. I still have a question that I have had swirling in my head for a very long time, and I feel kind of embarrassed I can't answer directly. I cannot clearly state when does something get saved on the stack and when does this get saved on the heap. And I absolutely know that is a kind of a job test question for a lot of people, and I don't know the answer. I don't know the answer between the heap and the stack. I clearly cannot articulate it. It's one of those things that I never needed to learn because it's not practical. I'm a very practical person. I write code to get shit done. I don't write code. When you malloc, it's always heap. Really? That's interesting. Okay, because I know malloc. We'll get there. That's memory allocation stuff. A variable declared outside a function is stored in globals. All right, we got that already. So they said to go slow, so I'm going slow. I'm going to sip my brandy. Set sail with pointers. Imagine you're writing a game in which players have to navigate their way around the Bermuda rectangle. Oh, okay. The game will need to control lots of things like scores and lives and the current location of the players. You won't want to write the game as one large piece of code. Instead, you'll create lots of smaller functions that will each do something useful in the game. He's having a brandy. Yeah. Malloc memory address is a form. You will always be able to add access to the data compared to the stack pointer, which will point to nonsense once the var goes out of scope. Interesting. Man, that makes it, that helps me understand shared memory IPC and everything else too, which I used. I wrote some Perl code that did shared memory IPC in Perl. And it was tricky. So shared memory IPC, by the way, is the fastest IPC method on planet Earth. It's the reason that the Linux kernel will never, ever be written in Rust, because you can't touch it. So I thank you for the fall. So as long as you know about address space, each process has its own address space. That part I knew. Yeah. All right. So I don't know what this is about. This is, okay, we're going to make all of these functions do things. What does any of this have to do with pointers? Let's begin coding without worrying about the pointers at all. You'll just use variables as you always have. The major part of the game is going to be navigating your ship around the Bermuda whatever, so that we can dive deeper into the code, and we'll need to do this. So we're going to write some code, and then we're going to jump into how pointers are behaved into the code. So let's get on with that. Also, to answer the biggest address thing, it depends on CPU mode you're in. If paging is set up and activated on x86-64, this is done through a CR3 register, you will be operating on a virtual address space, which doesn't really correspond to your RAM. Interesting. And it's architecture specific. For example, in log mode, ultimately underneath there, though, it's still accessing RAM, right? It has to. In log mode, it'd be x86, you have 48 bits of addressable space. If you're working with physical address space, then it does correspond to RAM, etc. Interesting. So there's some layer of abstraction that prevents you from accessing the RAM stuff and dealing with RAM constraints and architecture directly. That's cool. I apologize to the beginners out here. I'm selfishly asking a bunch of questions that I'm interested in as well as we go along this whole thing. But you can just stay with the book and you should be fine. Paging, you could be accessing an address which will look to the disk, which will look to disk, then correct. No, I don't think you can. I think if it's, as far as you're concerned, you don't care, right? The question I'm having, and this is a huge rabbit hole. The question I'm having is what happens when you access memory from swap space? And I know swap is a bad thing and nobody's using it anymore, but it just got added back. Kubernetes support for swap just got added back, by the way, because there are legit reasons to have swap. And so, hey, Tanawa. So if you have page, well, we'll get back to that. I don't want to get distracted with that right now. Appreciate that though. Thank you. I'll go back and read it. So set sail. Let's start. The game will track the location of players using latitudes and longitudes. The latitude is how far north and south the player is, and the longitude is her position east or west. North or south, east or west. If a player wants to travel southeast, this means their latitude will go down and her longitude will go up. All right. So you could write a go southeast function would take arguments for latitude and longitude. All right. So we have, let's see if we can write this without looking at it. Let's read the requirements and see if we can just write it. We know enough to just write it. So before we get into the solution, let's burn our brains up on this, trying to think of how would we solve this problem. So these are the functions we need to have. And we need to keep track of our position based on longitude and latitude. And we need several functions that are going to change that based on it. And we need to keep track of our position. And there's lots of ways we could keep track of position. I think we could probably do that by just having longitude and latitude be separate. And let's make them numbers, right? So assume they're going to be integers. So obviously when it's enabled to set to none. Low-level nerd chats. Yeah, it's pretty fun. So here we go. We're gonna do. I'm gonna make a new program. Let's call it Bermuda. All right. So Bermuda.c, and then we're gonna edit that. I don't have to schmod it or anything because it's just a source file. And we have Bermuda.c. So let's just, to feel good, let's go ahead and get something to print. I'll just make us feel good. Import, not include. No, include. Include, do you remember it? .io. .h. Int main. I mean, we've done it a lot, but we should have it memorized by now. And yes, I'm going to change my style to be compliant. I got 8 space indent. Don't judge me. I'll change it eventually. All right, so then we have what? Let's do something simple. Let's actually set an external, some external variables. So let's say we have lat equals 0. I'll have an int for long latitude and longitude. I don't know. Longitude. Lon. How about that? Latin lon equals 0. I know. Anyway, so let's get it to print. I mean, we know we're gonna have to do that, right? Let's make a function for it though. Let's say show position. I don't know. Did it tell us what to call it? Go west, go south, east, eat rat, die of scurvy, speak in present tense, make one sequel too many. They're making fun of pirates. So let's say show Taniwa. The status changed. It says C game development. Thank you very much. So position show position is all we need. And we're using globals. Don't yell at me. This is early. I see it now. Oh, God. So show position is not really a function at all. It's more of a procedure. What's the difference? What's the difference between a function and a procedure? If you've coded any Pascal, you should be able to spit this out immediately. Everybody else is going to be frustrated. Or SQL or PSQL. PSQL. Show. Yeah. That's one of the many, many differences, but it's a big one. Show position. God damn it. Me and my tomato. No, sir. Tell that to the functional programmers in the house. Okay. So show position. We're going to printf. And we're going to printf. Is it D or I? Let's use I. Latitude. Longitude. Latitude. Longitude. I backslash n. Lat. Lon. All right. So there we go. Now it should print 0, 0. Let's just go ahead and compile it. As you know, we've already updated our C flags. C flags. How appropriate with this pirate thing, and our bash RC, which I'm not going to tell you here, but so that we can just type make, and it will actually make it. Bermuda. In fact, if I make a makefile, I don't even need that. Should I do it? Should I do that? Then I'm really lazy. Oh my God. How lazy can I get here? What? When we have bash scripts. This is C we're talking here. I mean, this is C. I could make it in a build file. I feel it's appropriate to use make files for C. What do y'all feel? I know you can use C without a make file. You absolutely can. All right, fine. Let's do it. Let's write a build file instead. And I've already got build thing like bin bash, and then I could just do. You could just interact with the compiler through a script. Absolutely. We could just do, or we could just do this. Make Bermuda. So build. Fuck. Schmucks build. That's schmod plus X for the lazy out there. Damn. Make $1. Stop it. Just stop. I'm using make because make is the C tradition. If there's if there's one place you can use make without reproach, it is dealing with C. I mean, come on, you have to agree. It was invented for fucking C. For God's sakes. That's why it was used. So even if there's not a lot of dynamic link compatibilities and stuff like that, it's totally good. Who said anything about Go? Using make for Go is idiotic. Using make for Go is idiotic. There's no cross dependencies. Unless you look, if you've got a cross dependency on something else being built more newer than the other one and having the other thing need to be statically compiled and rebuilt, fine. Make might be useful for that. Oh God, exactly. Okay, I guess we're done talking about this. I'm gonna stick with just plain old make. And I'm gonna have to fucking type it every time, but that's okay. I don't know. How about we just build some Java with make files? God knows people tried. C and Go. So you can't use Go generate. Exactly. I'll let you fight about that while I do this. What did I do? Bermuda. Show position. I mean, this is where you get to make fun of all my mistakes. I'm trying to edit main. Can you believe that? I'm going to have to type Bermuda every time. What the fuck? Okay, so I should probably put this in individual directories. And then make would make a lot of sense. That might be something that we actually do. I'm going to put that I had. You know what? What if we did that? What if we did that? What if we actually made this a directory, which is a much better organization? Yeah, it keeps us nice and clean. Move Bermuda.c into Bermuda/main.c. See what I did there? And then we can cd into Bermuda, and we can set up a git ignore in here for just the one file, Bermuda, and now we don't have to fuck around with all the other git ignore stuff. And then we can just make main. What's it going to make it as, though? Actually, that's not going to build it as Bermuda. It's going to build... Oh. Now we could actually do the make file. For Golang would have a go test. I'm doing a make file. Yep. All. And we need to make Bermuda. And Bermuda is made out of main.c. Yep. And then we make nothing to be done for all. Bullshit. There's no Bermuda. Returning 0 in your main. Oh, I forgot to do that. Thank you. Yes, I forgot to return 0. Everybody's been saying to do that. I agree with that. There's no return here, though, because it's void. Right? I think semicolon the end of printf. Thank you. Thank you. That was all it was. Yeah, you followed just to say that. Thank you. All right, help me fix my make file. I don't remember make. Yeah, I don't remember it. Line 8, I got it. How did I do this wrong? I've totally forgotten make. See, this is why I use bash, because I don't remember make. Is it phony? Do I need phony, really? Oh, God. I was hoping I wasn't going to need phony. I already have that in there. That's already a built-in rule. That's already a built-in rule. I could have swore that was a built-in rule. I don't. Oh, that's why I need phony? Yeah. My bash scripts work very well. Yeah, I agree. I honestly, I got to relearn make. I've totally forgot it. So, yeah. Building an object all runs. Yes. I think we should probably... I thought that rule was automatically there already. Actually, if we do main.c and we make it into Bermuda.c, then we just do make it. It should just work, right? No, because it needs a target. And that's where the make file comes in. Oh my God. Bermuda is already present. So how do I do it? Do I do all Bermuda? Yes, that's it. All right. That's all I needed. And then I can just do make. I don't have to type anything else. I have to type Bermuda every time. So, and the reason this works is because there's a ton of implicit make rules that we don't have that we're cheating and not doing. So actually, we could probably put our LD library flags or C flags in here, right? I do make show position Bermuda C. So position. Why isn't that working? Return 0. Longitude and latitude. Oh, God damn it. Still position. I'm typing too fast and failing. So now we have Bermuda. And I can run it. I can do make test. Or make run. Make test. Are we gonna learn auto configure at the same time? We need to learn autoconf. All beginners need to learn. Thank you. Yeah, D, thank you for saying so. I finally got there. All right, so what do we got? We got Bermuda, and we got our main airshow position. I mean, we're getting there, right? So what do we else need? We need to go. What did it say? What are the requirements of the project? The game will need to keep control of a lot of things like score and lives and current location of the players. You want to write the game as one large piece of code. Instead, you can create lots of smaller functions, each doing something. I can tell where they're going with this. They're going to want us to do structures pretty soon. No auto-load tools. So what does any of this have to do with any pointers? Let's begin coding without worrying about it. And we're not going to do fucking object-oriented here. You'll just use variables as you have. A major part of the game is going to be navigating your ship around the Bermuda rectangle. So we're going to need a ship and position and all this shit. And I can tell they're going to want to get us into structures here. Oh, look at this. If it passes in... Oh, I know where they're going with pointers. I know where they're going with pointers. I can see it. I can see it. Lol. They're gonna send the reference to a specific ship's longitude and latitude in here as a pointer. That's what they're gonna do. I can kind of see it happening. All right, so which I would never do, but whatever. So that was all good. Let's make another one. Let's say, what did it say? What was the name? Go southeast. Okay. Go southeast. So does it return a true or false? Or is it void? It is void. All right. Void. It is booked before, I think. Do you not start with a game card first? Yeah, we did. Yeah, we did a card counting thing. Yeah, you could probably help us with this. Go, let's see. Go. I mean, but there's been a lot of tangents in this group because they're way more advanced than this. They're just laughing at me, but it's okay. They're supporting us. I know how to code. I used to know how to code in C. I don't remember anything. Volatile in C, please check this out. Example of such bad formatting is funny. Oh God, not right now, but okay. So we're gonna say int lon. Yeah, I don't. This stuff is kind of unnecessary right now. Let's comment that out. Maybe later. Let's comment this out. We don't need that right now. Integer lon and int lat. Actually, longitude and latitude. Which one comes first? Latitude comes first. At latitude and longitude. Long. Now, if you're coding Go, you could do this. Well, I don't want to confuse you. Never mind. I take that back. All right. So it's saying, all right, we're going to add, so latitude equals latitude minus 1. Otherwise, we could just say minus equals 1. Is that a thing? We're going to find out. Okay. So southeast means that we're taking one away from both. Oh, wait. No, the longitude increases because it's, yeah, plus. So and see, it's a thing. I know that would be even better, right? Yeah, let's do that. Let's do minus minus and plus plus, all of which are the same. And you should know this from other languages, by the way. Those are the same in Go and JavaScript and Python. They're all the same. I don't know if Python has it actually. So, what is next? Well, that doesn't help us because it doesn't change the position. It doesn't change the position. I have never thought that. What are you saying? Don't you dare. That's I have. No, that is not true. That was never true. Stop lying. I knew Perl had that like way before anything else had it. That was the first language. Fine, to be more descriptive than battery change. Yes, I do. I like that too, personally. The battery charging. I do. I think it's nice. I do. I think I agree with you Wait, this is a 1. It means I'm adding 1. And plus, if you want to add 2, you can do it with 2. I could change the numbers. Like maybe you want it to move up a little bit more, and you can just go change the number. You couldn't do that if you had it the other way. You had to go change the whole syntax. I'm a fan. I'm a fan of that idea. So, yes. Main, longitude, latitude goes south. Printf, avast. Now, oh my god, it's actually going to change the values. Because it's past 5 value. Oh my god. I have just had my mind blown. I've had my mind blown because it's past by value. Kernel, not next. You know why this freaks me out? Because it's not intuitive to me as a Go programmer. Because it's going to change the actual value. It's not changing it by reference. So if you were to pass a string in and you change the string value, it would be lost. It wouldn't change it. I'm really, really glad I'm going through this. No, I didn't. Bite your tongue again. It will not change? Is that what they're trying to show you? Are they running us into the rocks on purpose so we can see it doesn't change? Because that was what I intuitively thought until I saw it and I thought, oh, they're doing something fancy. Maybe I didn't know. We're going to find out. Okay, I'm going to reserve my... Because to me, it's not returning the value. It's not changing the actual value that's being pointed to. C scares and confuses Go programmers. For your information, I was coding C before I coded Go and before I coded any other language except for Perl. Yeah. And I did simple table manipulation in my Perl class of programming, so I know what the fuck is up. However, I haven't coded C in a long time. Look, the reason it was completely counterintuitive to me that it was going to change the values. I was like, that's not going to change the values. And then I thought, well, maybe I missed something about C that I can't remember. And now they're just telling me they did it the wrong way. Well, we're going to find out. This should not change the actual value. But I don't know. I don't know. We're going to see. Lol. Lat. Int lat equals 0. Int lon equals 0. Go southeast. Lat comma lon, and print that motherfucker. All right, so Bermuda, no change. Good. Now they're gonna. I know what they're gonna do now. Okay, I see. They did the thing where they ran you into. I do this to my students all the time. I run them into the wall, and then I tell them about how it's been changed. Hi, you're home, and you have different overalls.
I did. I brought an extra.
Wait. Come into the light.
I changed.
Come into the light.
To go to the gallery opening.
They're like fuchsia.
They're dusty rose.
Dusty. Okay.
And
dusty
you know
rose.
what? They were on sale today at Target. I just happened to look.
Hi,
for
Sam.
$25. So I ordered.
Ouch. What you want to get pet? Okay.
I ordered 5 more.
You ordered 5 more of the dusty
they
rose?
were 25. No, I ordered 2 more of these.
And then all different colors?
Green. So like you're gonna see me in coveralls.
Oh, I like coveralls a lot.
Because I was like, they're so good and they might never make them again. So I'm gonna tuck away a couple. So when I wear these out, you know, it's that whole like if you find a pair of pants that fit.
Yes, absolutely no.
All right, I'm gonna take her out.
The dog is happy to see you.
Yeah, she is. Audrey, you fed the dog, right?
Overloading is cancer. I agree. Happy should be better spend your time proper learning pointers. I kind of know pointers, but yeah. So let's do this. Let's pass. No, I'm gonna. They want us to take a reference to that. This is the thing that takes a reference, right? Yeah, that's the same as Go, by the way. And then this has to be. This is going to change to be a pointer. I'm going to guess at the solution here, and if I'm wrong, don't pay attention to me right now because I might be wrong. I'm just guessing because I like to run shit into the wall first to see and learn that way. And if we do that, then yeah, Am I correct? Okay, that's actually cool because that's what. Well, it didn't work. Oh, I didn't make it. Oh, it still didn't do it. You have to dereference. I thought I have to dereference here, right? This needs a dereference. Yeah. Make. Fuck. Maybe I shouldn't do this right now. It's an asterisk. The asterisk is the pointer dereference? I thought this was the pointer dereference. Now this takes a reference to the thing. That is the same as go. And this says dereference the thing that was referenced to. That's actually different in go. The value of address. So if you do if I did it with just like this, that would actually change the pointer. That would be doing pointer arithmetic. And if I don't, then it's going to know it is not. I don't think it is just like go. Because this would not be a dereference, I don't think. In an argument, unless of the functions. Yes. All right, let's try it. Thank you, guys. All right, let's try that. There we go. So that's the right one. All right, so that's what we were doing. This is the dereference of the pointer. If you don't do that, it will do pointer arithmetic, right? Pointers suck. Hey, Shivers. Welcome. C++ is a different language. C# is a totally different language. It's much higher level. There is a need for that as well. I love Go. Go is my favorite, serious language for all the reasons that are here. Go back to Go school. What are you talking about? I know about the dereferencing, and I know about printing pointers. Set 1 through C through the dereference of the pointer. All right, I don't remember that. I haven't done it in a long time. Mostly because I use interface types, and so I don't have to deal with that. If you're dealing with interface types, you don't have to deal with pointer dereferencing. Because the interface is a reference already. And if you're doing references on the struct, you don't have to deal with it. I just have to jump on it. Me too. So this is good. This is good practice. So this is a dereference of a pointer. No, this is taking a reference to the pointer, and this is a dereference to the pointer. So that means operate on the thing it points to. And this thing, it is arguably the hardest part of C. So I feel I figured this one out. So we want to actually change the longitude values of this one. So we need to pass a reference to that thing, which if you printed out the value of the reference is actually the memory address of the beginning of whatever the thing is, the integer, and it'll give you the memory address of the thing. So, in fact, I'm kind of curious. Let's do that. Let's do a P here. And I know I'm just riffing off the book. I kind of want to though. So I want to do lat, and then I want to do and lat, and then I want to do lon. Thank you for that, Paul. And then I want to do and lon. And I'm going to put that on its own line because it's getting kind of long. So I actually want to do both. We're going to make that Bermuda. See that? So this is the exact memory address of where that exists. And look at how much different it is. It's only 4 bytes away. So they're neighbors. So the memory addresses of the latitude value and the longitude value are only 4 bytes away from each other. Which makes sense because I'm on a 64-bit system, right? And 64 bits is 2 to the pointers. If you pass by value to a function, it copies the data. Yes. Pass by reference, it edits the value outside. Yes. And it make my life better if you look into C-Lang format plus whatever style I prefer to use a program so that it can auto-format for me. I don't know. I mean, a lot of people have been recommending C-Lang to me for that kind of thing. The C-Lang formatter might be worth looking into. And then what you're saying is you can make it any style you want it to for linters. I was actually looking at linters the other day and I like stopped. I was like, I didn't want to take time away from everybody on that. But I think we need to do that eventually. Just to prove my point, what are you doing? You're doing the same thing. Southeast XY. Same exact code in Go. Go is exactly the same code. All right. Good to know. Thank you so much. I could have sworn it was something different, but that's the thing with pointers. They're hard to remember. God, what are you guys posting now? You finished the whole project? Oh, you're doing it in C++. Look at you. Oh, we did it with the struct. Yeah, we can't do structs yet. Structs are awesome, but thank you for posting that, Sebastian. That's the way I wanted to do it. I wanted to struct immediately. I was already into... I love C structs. I was immediately into doing it with the C struct, and I was like, no, they don't want you to do that yet. Not yet. So I'm going to hold off on the struct for now. Yeah, the .C-Lang format file at the Formatter project, the editor plugin is just... Oh my God, really? Can I put that in my Vim on update like I do with Go? Assuming C has its own version, something like SDL2 for this. Yeah. Let's just go redo this book, but in assembly. Why not? Really? Shit. I love the variety of interest you have. ADHD too. Absolutely. Can you not tell? No. I don't think I've ever been diagnosed with ADHD. You should see the comments in my YouTube videos. I can't follow this fucking shit anymore. I'm out of here. I'm like, okay. I'll give you your money back tomorrow. Making games for the Game Boy now. Oh, that's super cool. That is super cool. That is great. All right. This does say game development. Technically speaking, this is game development. Okay. Okay. We're going to get to the graphic stuff. We're going to use SDL2 and Blasteroids. We're going to make an Asteroids clone by the end. By the end of this, there's an Asteroids clone that we make. And they don't tell you the answer. You got to figure it out. They tell you what to make, and then they say generally how to go do it. It's going to be fun. I can't wait. We're getting there. We're not there yet. I'm super happy just to make the Asteroids clone. That's like, I want that. Armchair psychologist, but obviously, yeah, God, yeah. I probably am. I'm probably diagnosable. Just organize the mind as a stack. Why do you think I have a Zettelkasten? People like me have to create things like a Zettelkasten so that we can remember all the shit that we've been like traversing to all the time and kind of try to paste it back together into something coherent. But God help you if you have to follow me. Makes it interesting, hopefully. Definitely obvious. All right, so like you said that you just code this in assembly. Game Boy games. I do not code in assembly yet. I want to. I bow down to people who can code this shit in assembly. That is not me yet. I think we did everything the book said though. So let's actually go take our reward and move on. More than I know, and that helps there. Absolutely. Tell you what, absolutely. I cannot I go back to my code or I read stuff that I've written. I'm like, holy shit, this is awesome. And I don't have any memory of it. And it's not just because I'm old. I don't retain anything. And I've never retained shit. I don't know what's up with that. I can process stuff. I like to think that it's because I put all my power into my CPU and not my like local cache, level 2 cache or something. I'm revisiting some ASM programming. Maybe it's because I'm drinking. You should knock a lot of Rust off. Yeah, look, I'm not going to bag on Rust tonight, but yeah. I would much rather learn assembly over Rust. So God, oh my God, it would be so much cooler. That's why I want to be able to honestly say I understand assembly. I think that is like one of the coolest. I mean, I'm 54 years old and I still have goals. And one of my goals is to be able to actually look people straight in the eye and say, yes, which kind of chip would you like me to code assembly in for you? Because I know it. And if not, I can look up where the registers are and I can figure it out. I can make you your device driver in C and assembly. Thank you very much. You know what? Even if I never get paid, and I probably never will, for that, I want to be able to say I can do that. I mean, that's like next level shit to be able to say that. And I can't say that. I never have been able to say that. I've always wanted, I've got books and books on my shelf of hopeful thing, like workout equipment for people that are overweight. They end up giving away eventually. And I kept all those assembly books and I've never once cracked one open and done it. I've mentored people who got jobs doing it and made their own circuit boards to code them in assembly, but I personally have not done it. One thing at a time. All right. So is basically is a language that allows you to do almost directly write machine code. Absolutely. And I actually love what's it called? Shenzhen IO, because it is kind of assembly, but it hurts your head. And sometimes I don't want my head to hurt. I want to blow people up. And that's why I play Crystal on Dota. All right. So here we go. Main, we got this done. This program starts to ship at location 3264. So if it heads southeast, the ship is the new position and blah, blah, blah. At first, it would be, at least it would be if the code works. Bum, bum, bum. We tricked you. This code doesn't work. Look up the code carefully. Do you think it will work? Why or why not? Initially, I said, this code ain't going to work. And I didn't bother reading this. And everyone's like, no, that code's not going to work. And I'm like, it's not good, because that was my initial impression, even though I allowed myself to be convinced by the code having been written there. So anyway, test drive. The code should move up to the... Whoa. Okay. C sends arguments as values. This is what Ancient Straits was, beating down our heads. Everything is by value. The code broke because of the way the C calls functions. Initially, the main function... my wife is making a smoothie, obviously. I like the writing style too. People think it's silly. I don't. I think it helps you remember it. And so do psychologists. So I trust them, and neurologists. The main function has a local variable called longitude that had a value of 32. When the computer calls the go southeast function, it copies that value and then it changes it. By the way, this burns you in Go all the time. I said neurologists. Thank you very much. This burns you in Go all the time. Anybody ever made a Go struct and not use the pointer for the receiver? And you're like, why the fuck is my code not working? It's because it's making a new copy of the struct every time. When you hang a method off of you know what I'm talking about? When you hang a method off of a struct in Go, if you don't put the asterisk there, it doesn't copy. It copies a copy of it. So another reason that Go really helps you understand the whole pointer stuff, because it has it as well, but it has it in a kind of a happier way, if you ask me. It's largely the same thing, but when it comes to structs and things, it's a little bit easier to deal with. Initially, the main function has a local variable called longitude. By value, by ref, what's going into the call stack. Their assembly insight to help with C. You know what? I'm glad you said that. I'm glad you said that. You have just given me an idea. Yes. Xclip. Xclip Bermuda.c. Now, we shall go... I've been trying to find an excuse to show people this. This is not part of the book, so close your ears. Happy little pointers. Close your ears. Close your ears if you don't want to see this. Compiler. Compiler emulator. This thing, somebody showed me this. Who showed me this? I think I VIP'd whoever it was. This is it. This compiler explorer, it still has my last project even in it. We were trying to figure out where the string literals actually created a cache constant reference in the constant area of memory, and it actually does unless you do modern GCC 11, and it does not do this. Somebody showed me this. Is super cool. It's like godbolt.org, and so if you go to GCC 64. Oh, it's super cool. So it is so cool. It will show you any compiler since the beginning of time, pretty much. So yeah, and so basically, there is There's C-lang is in here. But so let's actually do the current one. And it says C++ source. It's not C++, but it's okay. We're going to paste our stuff in here. And it actually does it in real time too. This is so great. So look at this. Isn't that cool? I mean, isn't that just so beautiful? So who was telling us about copying? So you want to learn assembly? Here you go. Here you go. This is it. Go strings are immutable. Go strings are immutable unless they're GCC 11. No, C. Are we talking Go or C? C. What are you talking about? We actually talked about that with string literals last time. String literals are immutable, but they're not what we think. They don't. The book has a misstatement. The book says something that's about an older version of GCC that is inline and optimized in modern GCC. So yeah, strings are immutable. So yeah, it's doing it behind the scenes. I have a feeling. So here we go. So go southeast. It says change the D word, substitute pointer RDI. Main. What is RDI? Read index. Oh, I don't know, man. There's a constant string. Character arrays, absolutely. We talked about that like 2 weeks ago or a week ago. This is a difference, yes. So here we go. Int latitude. So, God, it's so cool. All right, so let's do this. Let's go in one at a time. So, all of that is from this one line. All of that is from this one line. That's the line that makes this thing exist. Right? And then the return value. ESC, EXEX, move 1, I minus 1, XOR, EX. That's the binary stuff. All right, these are all bitwise operations, I think. I don't know. I have no idea. Call printf. So that says go to printf, which is built in, and XOR EAX. I guess that's just the end. Go southeast. There is no call. And so that means it inlined it, right? Did it inline it? It did inline it. Yeah. It just made it into pointers. This is so cool. That's compiler optimization. Divided by libc, which I guess it will be called dynamically. Yeah. Turn off optimizations. Yeah, you can turn off optimizations. This is with O3. If you turn them off, it will go back to like the full format. Yeah. I had them on by default. So now it does it the long way. So it goes all the way out. So we have this here, then this, and then this here is the call. So this says RDX RD minus 8 Rex, or I have no idea what that is. And then call int. So that goes up to here and does all of this. It got inline, yeah, reordered removes. Yes. And Go does that too. It just doesn't show you in assembly. I wish they would do a Go version of this. That would be so sick. Do they have one? Please tell me they have. Oh, holy shit. Holy shit. Oh my God. They have, oh my God. Oh my God. My heart just is like fluttering like crazy. Oh my God, my heart. This is so amazing. Godbolt.org. It's like, if you want to learn assembly, here you go. But see, look at all the optimizations that it did. Shit, I got to paste my thing in here now. I got to do the same code. Where's the code that you guys wrote in Go that does the same thing? This is so awesome. This is so awesome. I cannot stand how cool this is. I mean, this is so cool. Your own instance of it. Oh my God. This is so amazing. You can see Plan 9 ASM for the Go tool chain. You can. It's got Haskell. It's got everything. Do you want to talk about, look, if you want to actually, let's do Rust. Look at that. I mean, if you want to actually compare compilers, here you go. If you want to see how fast something is, Python's own compiler. Default main pass, that's their sample. Are you kidding me? Make functions. Oh, here's the bytecode. It has like the bytecode stuff. Anyway. It doesn't have Elixir? Oh. Perl would be crazy. The Perl compiler is insane. So, this is super cool. All right, let's go back to what we're supposed to do. God knows a good tangent for the purposes of education. Hey, look, 3 ohms followed me. First I read that it said threesome, and I was like, initially the main function. How much time we got left? We're probably almost done. Has this been educational? I hope so. We have to finish at 9:30 though, because my wife is home and she's making all kinds of noises in the kitchen, and I've had a nice cup of brandy. If you ask, initially the main function has a local variable called longitude that had value 32. When the computer calls the GoSoutheast function, it copies the value as the longitude value and the long argument. We already know what it does, right? It changes it. It just changed. Watch. I've had to debug this shit so many times in Go. I'm going to show you. So those of you who want to see what's wrong, let's pretend like we didn't know what was happening. Okay, let's go back to the original. And for those who don't know pointers yet, I happen to know pointers, so this has kind of been a reminder, obviously. I know about dereferencing and stuff because that's in Go, even though I had to be reminded that Go and C are the same when it comes to this shit. And we'll leave that for now. Okay, so you think, okay, I want to change the latitude and longitude. You pass it in, and you go in here and you change it, and then you get it printed out, and you're like, no, it's still 0, right? Bermuda. So let's go back to where we were. You get 0, and then here's the pointer addresses, which are 4 bytes offset from each other because, you know, 1 int regular short int is apparently 4 bytes. And so you're like, what the fuck? I thought I changed it. And so your first inclination is to add print statements, right? So let's do that. Let's do a printf. It's like, no, man, I changed this. No, dude, whatever your, thing is. You say lat, and you can say %i lon %i, and you're going to put your lat. You're going to prove to yourself that you did it right. I'm going to prove to yourself that you did it right. And you're going to make that, and you're going to say, okay, watch, I'm going to prove it to you. I did it right. See, it changed the values. You have no idea how many times I have had to do that exact same thing in coding Go. Because Go has pointers, and not only that, if you forget to put the pointer in front of the receiver on a method that's been hung off a struct, it doesn't change the methods. It doesn't change the struct values that you're changing during the method execution. It changes them on a copy of it and then discards it when it finishes. And it's really fucking insanely annoying because you can't find out what's going on. You're putting print statements in there like, this is right. But then after when it comes back after getting called, it's not changing it. What's the deal? It's almost as if it didn't change the actual values. It changed them in a copy. Because that's exactly what it did. This is why we can't have nice things. So, oh boy, what is this? Oh boy, find print zone position. Did you already finish the whole thing? Look at you go. You're done already. There you go. If you want the answer, you can look at Spazianato or any number of other person's finished projects. I'm going really slow here because it told me to. The book even said so. It said, and I don't do anything unless it's written in the book. You know me, right? So So this is obviously changing something. It's just not making it up here. You're like, oh, it's changing a copy of it. You know how you know? Watch this. Watch this. I'm going to prove it to you. I'm going to prove it. I'm going to prove to you that it's not doing what you think it's doing. Yeah. And this is something that you can do in Go, but is kind of the kind of thing you would do in C. Let's say, let's take a pointer to this latitude at this spot. Oops. Let's take a pointer to this latitude and this longitude over here. I mean, this is a much funner way to learn it, right? Funner is a word, I promise. Watch. All right, riddle me this. Why is this address different than this address? It's supposed to be the latitude. Why the fuck is the number different? When used unixly? Yes, that's how I'm going to be doing it. Did you add some other stuff to it? I can't wait to test my Kubernetes services tomorrow with it. I can't wait. We wrote a TCP/IP service that's interactive, has a REPL on it today for Go. In case you're wondering. So why is that different than that? Now, if I count correctly, let's see, 7FFE 48. Okay, FEAE. Wait a second. This says D8 and this says D4. How are those addresses different? Because what you changed is something different. It's a completely different area in memory. All right, so then you're like, well, why is it a different area in memory? And you're like, because Go and C, actually that's not true. Go is passed by ref in some cases and passed by value in others. So, but C, as Ancient Straits said very succinctly, is always pass by value. That means if you want to pass something shorter, you don't want to give them the whole thing, you have to take a pointer yourself to do it. It's not like built into the language like it is with Go and other languages. It's like you have to do it yourself. So that means you have to take a pointer to it. And that's what we didn't do. Even if it's a fucking integer. Even if it's a number. So in Go, the reason that this would have screwed me up in Go is because in Go, I think I still would have had to take a pointer to it. Yeah, absolutely. It wouldn't have been copy of a I don't know. Yeah, it's the same thing. Never mind. I got confused for a second. It's easy. I promise. So now what? Now we need to change this. Let's take, let's say, okay, the thing I'm passing in now is a pointer and not that. And then I need to change the thing that's being pointed to. This is a dereference. This says, give me the actual memory space that was pointed to by that pointer. If you don't do that, by the way, you watch what happens. It doesn't do at all what you think. This is crazy. This shit is, I won't even do it because it's not standard. Yeah. It won't even do it. So, yeah, because it won't even, you can't force it to do pointer arithmetic there. You can actually modify the address. It's called pointer arithmetic. And we're going to get to it later. And it's super weird and cool at the same time. God damn it. God damn you. All right, so now we can just put lat here and lon. Actually, we can put, I think we need to do lat and lon. No. We want pointer here for lat. And this is we want lat. And this is we want pointer for lon. And then we want lon. I know that probably just... Yes, please do a quick Docker file on that. I would love it. Yes, please. Thank you very much. So do it from scratch. Make sure it's from scratch, exe. That's the whole point of doing it in Go, right? I don't want any other stuff in there. So yeah, it should be like really tiny. That's why I think that's the smallest you can get a container, period. For Go anyway. In C you could go smaller, and Rust you could go smaller. You could get it down to 1 megabyte. 1 megabyte container. Yeah, which is fucking insane if you think about it. I love it. That's why I like Go that's why all the compiled languages are going to win for containers long term. Go and Rust and C-Lang or whatever, they're going to win because you get the smallest possible container. Python looks like a bloated behemoth, morbidly obese piece of shit compared to that. TinyGo possibly. Yeah. but it has to be from scratch. And then if you consider what command box brings to the table by adding modular commands, command box allows you to do modular commands and like plug them in, and so you can mix and match and put them all into your Go program, and now you have multiple commands built into your command. And that's why I did command box that way, modeled after BusyBox without knowing it, and then I saw BusyBox. So here we go. So lat is I think this is fine. I don't know if that's even gonna work. Let's try. Go east. Oh, we still have problems. Lat is a pointer. This should be what is referenced by the pointer. I think I had that right. I screwed up the other one. Yes, I did. Go southeast. Yes, this. Okay, so now we have to take a reference to the lat, and we have to take a reference to the longitude. That says, give me the address pointing to the thing, not the thing. Is being called a microservices container. Oh, glory, oh bliss. Yes. Ooh. All right, so we got this. Now look. See these numbers? Now they're the same. The address is now the same. It did exactly what we wanted. And the address, the pointer, the address, the memory address of the thing being changed in the function is the same as the one that ends up getting printed after the function finishes and returns. Because pointers, memory references. This is different than the other one. You remember the address was different between the two. So thank you very much for that. So that's fucking amazing. That's like really cool. That's fun. And I think that's the end of our Bermuda thing. As I said, go slow with pointers. If you want to play with more stuff and you're more advanced, go play with Compiler Explorer for what we just did. It's pretty crazy how cool it is. One over the other, pointers versus copies. Do you find that students expect one over the other? No. They don't expect anything. They really don't. The people that I've worked with anyway. Most of them have been jaded by JavaScript and Python, which just do the magical thing the right way. And so does Go, by the way. So, and the harder thing is to come to one of these higher level languages and to know what's up. Like, okay, do you pass, like any functional language, nothing is passed by value. Nothing. It's all lazy loaded. Haskell, for example, try to deal with Haskell. Even Python. Python's lazy loaded too. Somebody told me Python was lazy loaded. I was like, I had no idea. That's why Python can get away with doing comprehensives and shit that are like really expensive if they were operating on pass by value. Functional programming with pass by value would destroy the computer. Instead, functional programming kicks ass because it does lazy loading and everything's passed by value. And this is pretty advanced stuff. So if you're a beginner, don't fret. But I haven't done BrainF yet. That's why I think I want to learn it. But I would rather learn assembly before BrainF. I understand BrainF helps you think about assembly too, but I haven't learned it yet. So yeah, this is super interesting stuff. I really love it. It's a good reminder. Bottom line, pointers are numbers that point to a specific location in memory. And anytime you set a variable, you're adding something. If you're setting a variable in the int, this is the takeaway here. So, there's our binary that got compiled. When you set a variable, whether anything inside of here gets added to the heap, which is a different area of memory inside of the running program. That's actually in memory. It's not in the running program. The stuff that's in the running program, I think, is a part of the constant stuff, and that gets. I think they get loaded. This is what I need to know assembly. I think they get loaded into memory when the binary is loaded into memory because the constant's just a part of that, and so it's right there and it doesn't ever change. So anything that can be changed goes on the stack. Did I say that right? What did the book say? Stack or heap? Anything that's going to be changed goes on the stack. And I still don't understand the heap personally. It doesn't go on the heap, it says, though. I said it goes on the stack. Anything in here goes on the stack instead of the heap. And I don't know the difference. I don't understand the difference. I've been trying really hard. I'm still working on it. Don't give me, one thing at a time. The main takeaway here is if you want to change a value, you have to force. The main takeaways from today's lesson are C passes everything by value. So you don't have to guess. Python, JavaScript, Ruby, Go, I don't know about Rust. They all pass by whatever is convenient. So in Go, for example, everything, all maps and slices are passed by reference. Arrays, which are underneath slices, and integers and strings are passed by value, unless you tell it you want to pass it by reference. I think that's right. But you have to always look them up, because what they've done is languages like Go, in Python, they've taken the intuitive expected thing and they've done that instead of just saying, no, you have to say how you want to have it passed. And that's what C does. C says, you have to tell me exactly how you want this thing passed, which is nice because you can make a decision. You can say, look, this string might be up to, 2K. I'm not okay. At some point you want to say, and Go, you don't have the choice. Like it's always, one or the other, or Rust or any Python, whatever. Because all dictionaries shall be passed as this, right? But dictionaries have to be that way anyway because they're like complicated structs. So they have to be pointers that are really complicated. Stack memory is local to the functions, so that may be nature of the task. Call a function and change the value. It can't be on the stack. You can modify something on the stack that was local to another function. Don't know. I'll have to go look. So anyway, that's the takeaway. A pointer is an address to a space in memory, and when you make a variable, you create memory and allocate it for that initial value. And if you ever want to change what's in that value, in this case of 4 bytes of 4 times 8 ones and zeros on most systems. I mean, we're talking about sign bytes, so it would be 8 instead of 7 bits. And then what that means is that sometimes the way to represent a number or a byte is by 7 bits instead of 8. And that would be that extra bit actually can indicate positive or negative in a number kind of situation, depending on how small it is. I don't know that there's any. It would have to be a short, wouldn't it? Wouldn't it have to be a short to not use 4 bits? I'm basically saying if the thing I'm changing is on the stack, as soon as I return from my function, that data is gone. Thus, it's natural that if I expect my change to not be ephemeral like that, it must be in heap memory. Interesting. So anything that's got a pointer to it isn't freed from the stack. Is only the ephemeral stuff, right? I'm sorry, is only the ephemeral stuff. That makes sense. So that means there's a certain amount of memory allocated for a function, and it's like the scratch pad while the function's running, and then I don't know. That's interesting. Okay. Well, it does say that this stuff is written to the global section, so that would make sense, right? Because over here it's written to the global section because it never changes because that was predefined outside of the scope of a function. Interesting. That's super interesting. Thank you for saying that. I really want to get into that. They're going to get into it a little bit more later, but so far, yeah, unless the function ever returns, right? And that's the whole problem with garbage collection and releasing memory and shit, right? So this is the whole thing. If you're out there and you're thinking, oh, hey, I got memory problems, this is what garbage collection is for, right? So garbage collection constantly in the runtime is looking at everything on the stack and heap and saying, are you using this or not? Is there anything referring to this or not? And if it's not referring to it, it like gets rid of it. But if you keep using it over and over again, it will never get freed. And so that memory, so you can't do it. And then especially if you directly allocate memory, which we're not there yet. All right, test drive. Here we go. See arguments and values. We did all this. Go ahead and read that. Try passing a pointer to the variable. We did that already. We did all of this. Dumb questions. I print the location of the variable on the machine. It was 4, but there's something wrong. No, the memory location of the program used for variables will be different from machine to machine. What are the other areas of memory used for? You'll see other areas in the book. Okay. Pointers make it easier to share memory. Yes, we covered all of this. So now it changes that out and puts 2 in there. Using memory pointers, get the address of the variable. We already did this. We already did this. So putting a star in front of it says, I want to use the thing pointed to. This and sign says, give me the memory reference to the thing, and the star says, give me the thing that this address points to. And if you want to, you can use address of for a while. Some people will do EDR in front of there to help them remember that the pointer is actually an address. Because when you're first writing, when you're naming your variables and stuff, when you create a variable that is a pointer, that contains a pointer, it might help you put ADDR in the name, because that'll help you see it. But if you put ADDR in the name and there's no star there, usually that's wrong. Actually, no, that would be fine unless you wanted to get to the value and change it, and then in which case you would need this. Right enough, bookmark this. Oh God, you found a visualizer? That's insane. That's insane. That is really insane. Address operator and indirection operator. Yes, the address operator and the indirection operator give you the thing it's pointed to. Okay, change the content of the address. So you have to say change whatever this thing is, what is pointed to. It goes quick. Okay, now that you know how to read and write the content of memory location, it's time for you to fix the go south function, which we already did. We already did all of this, and you can do that on your own, but I did it already. Compass magnets, we already did this. Int pointers, dereferencing. This says I'm taking a pointer to. And this dereferences the pointers. Longitude, latitude, we take a reference to. That's exactly what we did to fix it. So, hey, we're good. Code works. Bullet points, variables are allocated storage in memory. Local variables live in the stack. Local variables. That means inside of a function. Global variables outside of the function live in the global section. Pointers are just variables that store the memory pointers to addresses which are themselves numbers. The AND operator, or the ampersand operator, no, the AND operator is a take reference of this, the address of operator, and this is the thing pointed to by this operator. And that is it. Our pointers actually address locations, or they have some kind of reference. They actually have numeric addresses in process of memory. They're numbers. We talked about that. What does it mean? Each process is given a simple version of memory. And memory is not like that. It's more complicated, really, but the details are hidden from the process, so the operating system can move the process around in memory or unload it and reload it someplace else. In memory, is memory not just a long list of bytes? The computer can probably structure the physical. I asked this question earlier, and we had somebody, a kernel developer, answer this. The computer will probably structure its physical memory in a more complex way. The machine will typically group memory addresses into separate banks of memory. Chips. Interesting. Do I need to understand this? For most programs, you don't need to worry about the details of how the machine arranges its memory. Why do I have to print out pointers using the %p? You don't have to use a %p string. On most machines, it can use li, although the compiler may give you a warning if you do, because it's an integer. The address is an integer. It's a number. Wrote even more insanity since I last looked. Oh, God. I don't know if I want to look. This is interesting. So Tim says Rust passes by value unless you use din traits as args. Anybody knows better? Yeah, I don't know that. That's super interesting. I figured with the whole memory safety thing, it would be more of a pass by reference kind of language. In general, that they would assume everything as a reference. That would be the way I would. I have no idea how Rust does it, but given their emphasis on borrowing memory locations and things like that, I would think that everything would be by reference in that language. But I don't know. And because it's higher than C and it's the same, I mean, Go does the same thing, but not everything's pretty much reference. Almost everything. If reading the content of a memory location is called dereferencing, does that mean pointers should be called references? Sometimes coders can call pointers references because they refer to memory and location. However, C++ programmers usually reserve the term reference for a slightly different concept of C++. But who gives a fuck what C++ coders are doing? It's a joke. It's a joke. Calm down. It's passed by value a bit like C. Is it? Priceless talk. Thank you for that insight. Thank you for that insight. I will give Rust another try one of these days. I'm just never using it for anything. But I do think that some of the concepts in it are interesting. It's like I want to learn brainf. I'm not going to fucking do anything with it, but I want to learn it. I do want to learn it. I won't lie. Because it does have some interesting concepts in it. Oh yeah, C++. Are we going to look at that? No. This book looks at C only. Thank God. 5 notable programs on the wiki, apparently. What? There you go. References themselves are values. They get passed around in C. That's true. In Rust. Oh, right. References themselves are values that get passed around. Yeah. But that's oh, I see. Okay. I know what you're saying. So it's strictly speaking, it's just like C. It's like it's passing by value, but the value is the pointer. I see. Okay. Because it's an int. Because it is a value. A pointer to memory is a value. It's an int. It can be cast as an int and everything. So, yeah. How do you pass a string to a reference? How do you pass a string to a function? We're not going to do that tonight. We're not going to do that tonight. A string is a character array, so we're gonna come back to that tomorrow. I'm kind of over time. Thank you so much. This is going to be a VOD, so I'm going to go ahead and cancel stream right now. And I'm gonna turn back on the stream for a conversation and stuff. I won't be here, but I'll have the fishes on. I honestly I don't have the energy to raid anybody right now. If somebody has an immediate suggestion for a raid, I'd be happy to do that. Otherwise, I'm just gonna leave the fish on and save my new changes. All right, so let's go ahead and add this. Let's go save it. So don't end our project without saving it, right? So I'm gonna do git add -a dot, which adds everything recursively to Git. I'm going to git put commit. I'm going to say I'm just about done. All right. So then we're going to say pass value or reference. Ooh, thank you for that reference. Add Bermuda from chapter 2. I'm going to git push that. So give here's the repo if anybody wants to go see the stuff that I did. Nothing fancy there, but go look in that if you want. Open issue if you have one on it. We have people done that in the past, and that's all for C. All right. I'm gonna just you can